Hello, I am Rolling Badmos and this is my YouTube channel. So here you will get mathematics and science lesson videos, difficult concepts made easy through well explained and thorough methods of teaching. To get notifications from this channel, subscribe, like and share. Share to your neighbors, share to your friends, share to that student, share even as a parent to other parents. Who have students and children in secondary education. I want to assure you that you are going to get lessons that appeal to the understanding of your words, of your children, of your students, and even you as a student. Thank you. Hi everyone. So today, first we are going to describe a segment. Second, we are going to derive the formula for finding the area of a segment of a circle. And third is we are going to solve an applied question, finding the area of the segment of the circle. Now, in previous videos, I've described what a segment is. I told you that a segment is a figure bounded by a chord and an arc. Is a figure that is bounded by a chord, right, and an arc. A chord and an arc. So this is a segment, and I remember I also said, right, that there are two parts, there are two segments in a circle. There is a major segment which occupies a larger area, and there is a minor segment which occupies a smaller area. So what we are going to do today is to derive the formula for finding the area of a segment. All right. So to help us do that, we need a circle, right? The center of circle O, right? We need a chord, okay? Two radii. All right. So this is what we're looking for. We want to calculate the area of the shaded part, right? We want to calculate the area of the shaded part. So let this be A, let this be B, okay? Let this be C. So we have radius OA, radius OB, the arc, length of a chord, length of chord AB, and then the arc ABC. Right, arc ABC. So we want to find the area of the shaded portion, right, which is a segment. How do we find the area of the segment? Now, take note that here there is a sector, right? First we have sector. This is, look at, we have a sector here. If you remember the videos, there is a sector here. So let's first label our sector. This is sector, let's say OAB, sector OAB, okay? So we draw out our sector. This is a sector, right? This is O, this is A, and this is B. Alright, so we have a sector. Now that we have a sector, now how do we find the area of the segment? Now again, we also have a triangle. Now, how do I, okay, let me draw that here. Triangle OAB. So we have triangle OAB. Now the angle subtended at the center of the circle is theta. So how then do we find the area of the segment? Now, to find the area of the segment, it is important for you, to bring out these two shapes, right? These two figures, the sector and the triangle. The sector and the triangle. So if you look closely, you will see that the sector, right, covers, everything here, both the triangle and the segment. Take note of that. The sector covers everything, right? The area of the sector is equal to the area of the triangle and the area of the segment. Look closely. All right, look closely. Again, now here, this is, although this is sector, right, but you find that there's a triangle inside the sector. There is a triangle in the sector, enclosed in the sector. So how do we find the area of the segment? This is the segment, right? This is the segment. So the segment and the triangle are parts of the sector. I'll say that again. The segment and the triangle are part of what? Of the sector. So it is therefore we can triangle are parts of the sector. I'll say that again. The segment and the triangle are part of what? Of the sector. So it is therefore we can conclude, right, that to find the area of the segment, okay, just to help our understanding, let me put this down. Area of sector is equal to area of triangle plus the area of segment. Pardon me. Area of segment. Again, area of sector is equal to the area of the triangle, right, plus the area of the segment. And that's because the triangle and the segment, both of them, they come together, right, to form a sector. So let's go on from here. So here we can make the area of segment the subject of the formula. All right. Let us make area of segment the subject of the formula. So area of segment, right, will be equal to the area of sector minus the area of the triangle. So area of segment is equal to the area of the sector minus the area of the triangle. That's how to find the area of the segment, to derive the formula for the area of segment. Now, what is the area of sector? We have done this before, right, in previous sessions. So area of sector is theta over 360 degrees times pi r squared. All right. So minus area of triangle. You know the formula for area of triangle, right? Area of triangle we use half base times height. I know you're familiar with half base times height. You can use that to 1/2, right, times the base of the triangle times the height of the triangle. Half base times height. That's the formula for calculating the area of a triangle. Although there's another formula just in case theta is given. And you can use it as 1/2, right? AB sine theta. 1/2 AB sine theta. 1/2 AB sine theta, where AB, right, represents the two sides, right? In this case, the radii. So here we can as well write it as, instead of writing AB, we can write r squared. All right, that's the two sides, a times b, r times r. So half r squared sine theta, just in case, right, the value of theta is given. All right. So now that we have this, okay, theta over 360 times pi r squared minus half base times height, or we use half r squared sine theta. Now we can go on to factorize. So we say that therefore area of segment is equal to, all right, let's maintain the second one, is theta over 360 degrees times pi r squared, right, minus 1/2 r squared sine theta, right? 1 over 2 r squared sine theta. So if you use this formula, right, you are going to get your answer for the area of segment. However, if we think, okay, you want to factorize, right, you can go ahead to factorize, to look at both sides. What do we have common to both sides, right? Radius, r squared here. Can you see that? R squared here. So r squared is common to both sides. R squared is common to both sides. R squared is common to both sides. So we simply write it out. R squared, open bracket. So here we have pi theta over 360 degrees, right? Minus here 1 over 2 sine theta. 1 over 2 sine theta. So this is the formula for calculating the area of the segment of a circle. The area of the segment of a circle. Now let us take an applied question. Example. Find the area of a segment of a circle of radius 7 centimeters, subtending an angle of 60 degrees at the center. So let us find the area of the segment. Area of the segment of this of the segment of the circle. So we are going to draw a circle with center O. Center O. Now don't forget, since what we are looking for is a segment, so we need a chord, the radii, right? Subtending an angle at the center of the circle, that's 60 degrees. Okay, now this is what we're looking for. The area of this segment, right, is what we're looking for. So there is radius 7 centimeters. Radius 7 centimeters. And let me say that in this the formula of this triangle, half r squared sine theta. Now here r squared simply refers to the two sides, right, that bind the angle, right, subtended at the center is what we have here. So sometimes maybe in some other parts of geometry, right, it's not always r, it's not always radius. In other parts it could be anything, like the one I mentioned earlier, half AB, right? AB simply refers to the two sides that bind the angle in the middle. The third side is C, right? The third side is C. So the two sides that is binding the angle, right, is what we multiply together and we add here. So that's it. So this is the diagram. So the next thing to do is to apply our formula. Is to apply the formula to find the area of this segment. So area of segment. Area of segment is given as r squared into pi theta over 360 degrees minus 1 over 2 sine theta, right? Sine theta. So r is 7 squared. Pi is 22 over 7 times 60 divided by 360 degrees. This is also in degrees. Minus 1 over 2 sine 60 degrees. So we are going to make use of special angles here. Alright, sine 60 degrees. So let's see how far we can go with this. This is 49. Okay, 60 here is 1. 60 here is 6. So we have, like we solved the other time, 22 divided by 42, right, minus half. Now sine 60, going by special angle, is root 3 over 2, alright, I want to make sure that I solve in fractions, all right? I solve in fractions. So here we can, let's continue this 49, right, into, let's break this down. Let's see what can divide this. Let's see, this will be 11 over 42, that's 21. Okay, 11 over 21 minus root 3 divided by 2 times 2 is 4. Alright, so let's simplify the one in the bracket first. Let's simplify this. Alright, so we have, this is 49. Right, so let's solve the one in the bracket first. The LCM, 21 times 4, that's 84. 84 divided by 21 is 4. 4 times 11 is 44. Minus 84 divided by 4 is 21. So here we have 21 root 3. 21 root 3. Alright, so the next thing to do is to simplify further. Now, let me say that I actually do not have a calculator here. Alright, that's why this is, but if you have your calculator, what you should do is that once you have simplified this, just use your bracket, use your calculator to solve the one inside the bracket first. Right, the one inside the bracket first, punch your calculator, 44 minus 21 root 3, get your answer, divide it by 84. Alright, divide by 84. So once you get your answer inside the bracket, multiply it by 49. So I'm also going to use my calculator, and then to solve this, I'll write the final answer. Alright, so we solve 49 into 44 minus 21 root 3 over 84. So like I said, use your calculator. So here we have 49. So 44 minus 21 root 3 will give us 7.63 approximately divided by 84. Right? So this is 49 times 0.0907. So our answer approximately is 4.5 centimeters squared. Alright, so the area of the segment is given as 4.5 centimeters squared. So let me know if you have any question. Thank you. Alright, so I hope that lesson was effective enough to help your understanding and to help you learn better. I want to believe that you've gotten better than before. So if you have not subscribed, do well to do that. Subscribe, like and share to everyone around you, so